Alright, hello. In this video I'm going to be talking about the current printer project that I'm working on, the progress that we've made so far, going over the CAD, just like the general ideas of the projects and what the next steps are before we actually get to printing. Yeah, so let's just get right into it. I think I'll just talk about some of the CAD first. I'll just show all the parts of the printer in the CAD so far, and then I'll actually show some footage of the actual physical machine I've built so far. It's not printing. It's not printing yet, but I figured that now that the actual physical machine is finished, I think then at this point it's appropriate to make a video about the progress so far. So yeah, let's start with the CAD. So this is what we've done so far. Currently the enclosure is muted out because it kind of obscures the view a little bit. We'll get into that later. Yeah, so this is, I'm calling it the Dancer Mark 1 so far. And it is a 4-wheel drive cross-gantry Cartesian printer with a triple independent Z-axis. And everything sits on a frame that's made of 8080 and 4080 aluminium profiles. So it's quite a lot bigger and sturdier than just your standard 20mm extrusions. And yeah, so this kinematic, if you're not familiar, this is something that you might have seen on the Annex Engineering K3 or Ultimaker printers. Actually, these type of kinematics are sometimes referred to as Ultimaker style kinematics. And the way it basically works is you have two linear rods in this case that are crossing over each other, and as these linear rods move around along the X and Y axes, wherever the two rods intersect is where your tool head's going to be. And in this case, yeah, we have our two linear rods crossing over each other, and each of these at the ends sit on MK1 linear rails, and these are and each side is controlled by a motor tower. So either end of each rod is driven along its axes, and yeah, it's a pretty cool kinematic. I personally just think it's a lot kind of cool and funkier than your standard like Core XY. And it has some good speed potential. Unlike Core XY, it has full motor utilization when going diagonally. So when you're moving just along one axis, it uses just 2 motors, and when you go diagonally, it uses all 4, which is the opposite of Core XY, where if you had a 4-wheel drive Core XY, you'd only have 2 motors moving when the head's moving diagonally, and then all 4 moving when it's moving in when it's moving straight. I think I've got that right, yeah. Yes. And yeah, so in this case, on each corner we have these motor towers here with a NEMA 23 motor on top. So again, much like the frame and the rails, it's a little bit bigger than you'd see on most printers like Forons, for example. And yeah, let's actually just look inside one of these motor towers and just get all this stuff out of the way. Okay, so if we just look inside, it's actually a pretty simple construction. So you have obviously the large printed case, and then inside you have 2 kind of areas within each motor tower. This area over here is the drive. Okay, that didn't work. You have a drive side of the tower and a tensioning side of the tower. So in this case, this tower drives the x-axis. The x-axis being the linear rod that the y-axis moves along. And how it works is, so if these gantries here, moving left and right, is the x-axis, your belt loop loops around, they attach to the gantry, they loop around into one motor tower, where it's driven on one side. The belt loops back around into the opposite motor tower, where it feeds into that motor tower's tensioning side. So this basically means that each axis has two diagonal motor towers driving them, and the other two diagonal motor towers are the ones tensioning that belt loop event. I don't think I used the best wording for that, but I think it's pretty straightforward. You have your belt loop, which is driven on one side of one motor tower and tensioned on one side of another motor tower. And yeah, so all of these motor towers are identical. It makes for pretty easy construction. Like the towers themselves are quite easy to assemble. They really are just screws, shoulder bolts. It's only a couple of idlers, pulley, and pretty straightforward construction. And then that's just repeated identically 4 times. So it's the same motor tower on each corner of the printer, with the diagonal tires with the towers diagonal from one another, controlling one axis. So these two towers, this one and this one, these control the x-axis, and then the other two towers, these control the y-axis. Yeah, let's just make that look normal again. Yeah, and then for the triple independent Z, it's again pretty straightforward. You just have a main sled attached to, again, 15mm rail. Oh, and by the way, the 15mm rails theoretically aren't like the most optional. It's not really needed to have rails this big, but anything smaller than the 15mm rail doesn't really fit on these 80mm profiles. There's just not enough flat space for the rail to sit on. 12mm rails would just be too small. It is a bit overkill with the frame, but we'll speak about that a little bit later. Yeah, so for the z-axis, you just have your main sled on one side, like your drive side. We have a z-wobble, like the Wobble X setup. Yeah, and then the other side, you just have two little 8mm linear rods sitting on top of each other, with a little sliding component sitting on those, which the bed actually sits inside of. So it'll be looking to here. Let's move the bed out. Yeah, you'll see this little sliding component. It's just two LMU8 bearings on these little linear rods, and then this is all just printed, and it's just a magnet down here, and then you have 3 little 5mm dowel pins facing each other, which your steel ball mounted to your bed can sit in. And yeah, this actually allows for quite a large range of motion for the bed. It can really just go any direction you want, and I guess the longer you make these rods, the more range of motion it technically has, I think. I guess obviously there's a limit to it, but yeah, so obviously, I guess theoretically this machine will be future-proof for non-planar printing, though I don't think that wasn't the intention. There's a specific reason for using this kind of weird linear rod setup that I'll speak about in just a moment. Yeah, in the CAD, you'll see there are planetary gearboxes on these motors. That was originally the plan, but I prefer not to have to buy a bunch of these, so I'm just going with regular NEMA 23s on the actual physical machine, because good quality gearboxes aren't cheap. Same with these. I originally planned for these to be ball screws, but again, that's like quite expensive, so I just went with regular 12mm threaded rods instead. Yeah, so the build volume of this is around 300mm in each axis, plus minus just a little bit. And so that's all well and good, but the main point of this printer is let me just, where is this? is the main point of this printer is this subframe here. So like the main this I guess you could say this printer is supposed to be kind of a proof of concept for. I struggle to find exactly what like the best like correct terminology for this is, because it's not something that like on most consumer or hobby level printers exists. It's basically having a cold outer frame and a hot inner frame or hot subframe. This is actually the reason why I chose these kinematics as well, partially, is basically to keep as many of the components of the printer, all of the kinematic components, all the drive components, all electronics, just everything possible, all the belts, they are outside of the warm enclosure of the printer, completely isolated, and only the components that strictly need to be inside of the enclosure are inside of it. Yeah, so the way it kind of works is you have this, you obviously have your main frame that everything's built onto, all of your kinematics and so on. Then you have all these printed parts. Actually, let me just isolate the subframe. There we go. Yeah, so you have this subframe, which is just printed ABS parts screwed onto the inside of the frame. And what this, and then, I'm bad at speaking, and you'll see these black things here. These are basically brush or bristle seals. I've got one of the parts right here. So if you see that here, printed, and then you screw with these holes into the frame, and then you have, whenever there's something that needs to reach into the enclosure, for example, the linear rods for X and Y, what they do is they reach through 2 rows of these bristles that are facing one another. I only have one here, but just imagine I had 2 of these and they were on top of each other, so it was like two lines of this stuff facing one another, and this basically allows a rod or just a smooth object to pass through and then move through it. Then the bristles kind of create a seal around it. Obviously not like a tight seal, but enough to kind of keep the heat in, so that you can have basically an enclosed chamber slash heated chamber, which is completely thermally isolated from the rest of the printer, including the frame, including the kinematics, just anything that would be negatively affected by excessive heat. And so the kind of idea behind this is that, I should say, I kind of first started thinking about this a couple of years ago. I was doing some research on adding active heating to like Vorons, rag rigs, those type of machines. And what I generally found is that it's discouraged, primarily because it's just like a potentially dangerous upgrade to make, adding heating elements to things. And if someone's not too experienced, that might be dangerous. But something that did keep coming up was that the way that those kind of machines are isolated, the way those kind of machines are enclosed, it's really just kind of screwing plexiglass onto the outside of the frame, which works. You can use that, but then that kind of exposes a bunch of stuff to that warm enclosure, which theoretically is detrimental, like your timing belts, your motors, all the printed components of everything don't necessarily work optimally at elevated temperatures. It increases wear. Everything just kind of acts as a heat sink, and then different parts of your printer, particularly the frame and the rails, they'll have different coefficients of expansion, I think is the correct word. Where basically the heat, imagine your printer's heated up to 70 degrees C. Well, your aluminium profiles are going to behave differently than your steel rails than all your plastic stuff. So everything kind of warps and behaves differently than if it was just at room temperature. Yeah, so all of those things are not necessarily like a complete bad thing, because realistically, that's how people have been building their printers and they work just fine. But it's like theoretically, not having to deal with that and having all of that stuff be isolated, that is theoretically a benefit. So this printer and the way it's constructed is kind of just kind of a test to see, just to see how viable this kind of thing is. Is this something that is worth integrating? Can you actually see benefits? Yeah, I think, yeah, that's kind of like the main reason behind it. It's definitely overkill, not strictly necessary, but I think it's an interesting idea, and I think it could prove to be effective. I think particularly for just kind of like the energy usage, like there's a much smaller volume of air that's having to be kept warm as compared to the size of the printer. And yeah, like I know, just comparing to another printer, the main printer I use at the moment is the GD+4. And whenever I preheat it with the chamber heating on, like even up to like an hour after I start preheating, I still hear things just moving and cracking and just kind of like changing. And I think that's actually why that machine in particular has had a lot of people report who have had issues with first layer consistency and like some print issues. I think it's just because when it takes a long time for a machine to heat up to heat up, and as it does that, it changes shape, it changes the way it behaves, and if it's doing that while you're printing your first layers, it's not going to print very well, and that's why you have to preheat. And I think that with a printer like this, where all like the mechanical stuff, all the stuff that actually does the printing, is not affected by temperature, I think that you could actually see some improvements for print consistency, first layers, and stuff like that. Yeah. I mean, I don't think there's particularly much more anything more I can show in the CAD. Like, I guess I could say what's missing. So at the moment, you'll see this tool head isn't complete, because it's not. I did originally have the tool head design finished. Actually, I think it still is buried in here somewhere. Yeah, old printed parts. Yeah, but I decided to just kind of redo it, because originally I wanted to use a mechanical probe for the bed, but I've recently started using a beacon probe on a printer at work, and it's just it turns out the beacon is really, really nice to use, and it's a lot easier to use than I thought it was going to be. So I think I'm redoing a couple things just mainly to use the beacon probe, but also while I'm at it, might as well just tweak a couple things here and there. Yeah, so I think there's not really much more I can show in the CAD. Yeah. Oh yeah, I mean, this is why I have these like kind of like long linear rod arms for the on the z-axis, so that it can reach through the bristle seals, because if it was like a big bulky printed part with a rail sitting on top, you wouldn't be able to create a seal around it so well with the brush seals. Yeah. Yeah, and of course that's why we went with the cross-gantry kinematics, because it's the only real way to have a kinematic where you have all your belts on the outside. Of course, if this was Core XY, your belts would be running to the tool head, so they'd be constantly exposed to warmth. Yeah, I can't really think of anything that is really worth showing at this point. So let's just move on to the physical machine. Can't see it in frame right now, but it's sitting right on the floor right next to me. Yeah. So this is the machine that we've built so far. Yeah, so as you see, obviously the enclosure, the subframe, is not finished yet. I've only just started printing out the parts. For example, this part here, it will belong, okay, in this corner here. You can kind of already see how this is going to work. I only have one hand free, so I can't move the rods, but you'll see the kind of rod sits in the brushes, it creates a kind of seal around it, and then we'll have another one coming from the top. And these can move through with actually pretty minimal resistance. I think actually, can I move it with my arm? Yeah, kind of. Yeah, so you can kind of get the gist of it. That's how that's going to work. I've only printed one of these so far. I'm printing all of these out of ABS, just regular ABS. These are really bad for warping. Like, I kind of causing myself some trouble trying to print these out of ABS, but I think it'll be worth it. And yeah, all the rest of the parts, like these motor towers, the gantry, and the Z-axis and stuff, this is all printed out of Cheedy ABS glass fiber 25. It's like the glass fiber core ABS. Works fantastically, creates awesome results. Though they're not really coming up in the camera well, but these are really good print quality, trust me. Yeah, so we have all the motor towers obviously built and installed. Motors are ready to be put on. They just haven't actually attached them yet. And of course, tool head is still missing. We still need to finish designing that and printing it. The Z-axis is basically completely installed. So obviously we have our bed here. Yeah. So as I said, we're using just regular 12mm linear rods. I ordered these kind of with like the ends that were machined to like an 8mm diameter. Just, yeah. They seem pretty nice. They have a 3mm pitch, and I'm actually using a plastic nut on them. And I saw that these were actually cheaper than the brass ones offered on the site that I ordered these from. And I figured it's probably convenient to not have to grease your rails as much, so we'll give them a shot. Yeah, I'm not sure. Should be good. Yeah, obviously you have your Z-wobble here. Actually, if I turn the printer around, we can see how it works, because this I've already constrained this one at the top, so you can't really see the range of motion that provides. This whole machine's really heavy. Yeah, so here I don't have this rod fixed at the top yet, so you can really see just how much freedom of motion that Wobble X allows. Obviously, it's not meant to be correcting for such big movements. Just imagine on a much smaller scale, any imperfections in the rod will be kind of dampened a little bit. Yeah. Yeah, obviously electronics and everything not installed yet. I've got actually. This is not the electronics housing I'm going to be using on this printer. This is from an old project that's didn't work. But just imagine something like this. I'll probably have like the Annex K2, is it K2 or K3? I don't really know. Kind of like have an electronics backpack on the side. I like the accessibility of that. Also because this printer because of these frames, is so heavy that having to turn around the printer or like flip it up to access the electronics, that's just completely out of the question. So I think a side-mounted electronics backpack will be good. Yeah, we'll be using the Big Tree Tech Kraken, just Raspberry Pi 4. Those will be our electronics. Yeah, I mean, that's pretty much it. I can't really think of anything else that's really relevant that I really need to talk about. And this video has been a introduction to this project. As we add different parts, like the electronics, the tool head, the subframe, I think I'll make little update videos just on the state of the printer, where we are, and yeah, I hope that I have a bit more free time coming up in the next couple months, so hopefully you'll be able to start making some good progress on this printer. And I'll try and upload updates as they come. So yeah, if you have any questions about this project, just let me know. Any suggestions, let me know as well. Yeah. Anyway, thanks for watching. Cool. Thanks. Bye.